So today we're going to discuss trigonometric function. How do you differentiate trigonometric function? So first, we'll start by the derivative of basic trigonometric function. So sin x, cos x, tan x, cot x, so like that. So trigonometric function. So if y equals to sin x, then the y dx will be equals to cos x. These are the basic trig functions. So if y equals to cos x, so then the y dx will be equals to minus sin x. If y equals sin x, the y dx equals to cos x. If y is equals to cos x, the y dx equals to minus sin x. You have to keep this in at the back of your mind. It will always come handy while you're differentiating. So now, what if y is equals to tan x? So if y is equals to tan x, so this is where we have to apply some other differentiation techniques to differentiate this. So if y is equals to tan x, from here, we know that tan x is equals to, from trig, sin x over cos x. So that is from what we have now is a fraction, like rational function. So that means we need to apply what? Quotient rule. Quotient rule to differentiate this. Don't forget quotient rule. So if you have not forgotten quotient rule, that means quotient rule says that if y is equals to u over v, then the y dx will be equals to v du dx minus u dv dx, everything over what? V squared. V du dx minus u dv dx, everything over v squared. So you take this, you differentiate this, minus, you take this, you differentiate this, all over, you square this. So from here now tan x equals to sin x over cos x. Now to find the y dx implies the y dx will be equals to, so we use quotient rule. V, what's our v? Cos x times du dx, you differentiate u. What's our u? Sin x. So what's the derivative of sin x? That's cos x. Cos x minus u. What's our u? Sin x. Sin x. dv dx. What's our v? Cos x. Now differentiate v. The derivative of cos x is what? Minus sin x. Minus sin x. Everything over cos x. V squared, right? Everything squared. Then d dx of tan x will be equals to cos x times cos x. That's what? Cos x squared, or cos square x. Cos square x minus sin x times sin x minus and minus, we have plus. Then sin x times sin x, that's what? Sin squared x. All over cos x squared is the same thing as what? Cos squared x equals to, remember in trig identity, cos square x plus sin square x is what? 1 all over cos square x. Also in trig identity, don't forget that sec x is equal to what? 1 over cos x. Sec x is equal to 1 over cos x. So that means if we have, then if you square both sides, that implies that 1 over cos x, everything squared, which is going to be equal to 1 over 1 squared is 1. Cos x squared is cos square x. Also will be equal to, if you square this, that means this also will have square. It will be equal to sec square x. Sec square x. So that means the whole of everything that we have in 1 over cos square x equals what? Sec square x. Sec square x. So that implies d dx of tan x equals sec square x. The derivative of tan x is equal to what? Sec square x. So let's quickly run through cot x. Find derivative of cot x. So we want to find the derivative of cot x. So from what we have here, from trig, we know that cot x is equal to cos x, just inverse of tan, over sine x. Cot x equals to cos x over sine x. So here now that means we have another fraction, so rational function. So that where we have to use quotient rule, right? So implies that d dx of cot x will be equal to, remember we use quotient rule, v, you take v first, sine x, du dx, you differentiate u. What's the derivative of cos x? That's minus sine x, minus u, you take cos x, dv dx, you differentiate the denominator. The derivative of sine x is equal to what? Cos x, all over v squared. What's our v? Sine squared. Sine x, everything squared. Sine x times minus sine x. So from what we have here, you realize this will be equal to sine x times minus sine x, that's minus sine squared x, minus cos x times cos x, that's what? Cos squared x, all over sine x, everything squared is what? Sine squared x. See that? Minus sine squared x minus cos squared x all over sine squared x. And this will be equal to, so minus is common, you can bring out the minus. We are going to have sine squared x plus what? Cos squared x all over sine squared x. Sine squared x. So everything is minus sine squared x plus cos squared x all over sine squared x. So that means d dx of cot x, that is the derivative of cot x, will be equal to minus sine squared x plus cos squared x. Remember from trig identity, that's 1, all over sine squared x. So that means we have minus 1 over sine squared x. So but from trig identity, from trigonometric, so we know that 1 over sine x is equal to what? Cosec x. So which implies that 1 over sine x, everything squared, also will be equal to what? Cosec squared x. So, and 1 over sine x, everything squared, is the same thing as 1 over sine squared x. That means since 1 over sine squared x is the same thing as 1 over sine, because 1 over sine squared x will be equal to 1 squared, that's 1. Sine x, everything squared, that's sine squared x. So that means 1 over sine squared x will be equal to what? Cosec squared x. So which implies that d dx, derivative of cot x, don't forget our minus, please. Our minus, 1 over sine squared x equals to minus cosec. So of cot x will be equal to minus cosec squared x, minus cosec squared x. So from this class down, so what we've been able to solve is that summary of the derivatives is what I want to write now. So summary of the derivatives, it implies that d dx of sine x, that is derivative of sine x, equals to cos x. d dx of cos x equals minus sine x. d dx of tan x equals to what? Sec squared x. d dx of cot x equals minus cosec squared x. So all this, you have to commit them into your memory, as we are going to be using it in other differentiation. So this is what I'm going to stop in this class. So if you haven't watched other tutorials like derivative of quotient rule, product rule, check my channel. I have them. So I drop mathematics tutorial at 5 p.m. West African time every single day. So in the next class, we are going to look at solution of some trigonometric functions. I'll see you in the next class.